All right, welcome back, the genius. Okay, so in this session, let's talk about string immutability in JavaScript. All right, when you say that something is immutable, that means it cannot be changed. After creating it, you can't change it. Basically, in every programming language, whenever you hear immutability, that's what it means. So in JavaScript, string is immutable. So we are going to explain it, understand some concept about it so that we get to understand it. And anyway, the more you understand this, the better working with strings would be for you. It will be easier for you working with strings. So let's dive deep. So in JavaScript, strings are immutable, meaning that once a string is created, its value cannot change. All right? Its value cannot change. Once you create a string, its value cannot change. So, the immutability principle has a few important implications and behaviors in the language. Now, if you really understand this very well, you're going to be working with strings well, and you could be writing a better program, writing a better code. So, strings are immutable. It means that once you create a string, the value cannot be changed. All right. So, we are going to see these are some, let us take a look at some concepts here. So the first one we see, let us see creation of string and assignment. Okay, so when we create string and when we assign, what are we really doing? So when you assign a value to a string variable, the string is stored in the memory as an immutable object. When you assign a value to a string variable, the string is stored in memory as an immutable object. Now, like when we were talking about variables, I told you that variables are basically temporal locations in the memory where you store stuff. And basically, when you create a string, the string is stored in memory as immutable object. It means that it cannot be changed. Okay, so any attempt to change the value of the string, such as maybe modifying a character in it, will result in the creation of a new string rather than altering the original string. Now, let's assume that you created a string, let string equal to hello world. All right. Then you now want to change a character of that string. You are not going to change it. What will happen is that a new string will be created. So whenever you see us modifying anything, we are not creating, we are not really modifying it. We are creating a new string. That is basically what it is. So I'm going to explain with this example. Look at this example here. We are creating let string equal to hello. And in the second line, we are saying the first character in the index 0, we want to change this H from to H to small letter H. And when you even console this, you can see that we also got hello. So let's do more practical here. Okay, so let string equal to hello. All right. And we are now coming to say, okay, we'll say string of the first character. We want to change it to a smaller, a lowercase h. And here we want to let us confirm whether it was changed. It wouldn't because the original string didn't change. We didn't change the original string. So if I run, all right, you're still going to you'll be wondering why didn't, of course, it's supposed to change, right? But you'll be wondering why didn't it change? It didn't change because you cannot change, strings are immutable. Strings are immutable. Do you understand? So that is why. So this would not work. This second line here will not work because you cannot change, you cannot modify it this way. There are other ways you can use to actually modify it, but this way you can't modify it this way. So whenever you create a string, all right, you can't modify it. Okay, so understand that strings are immutable. Once you create them, all right, you don't alter the original string. All right, so what we are trying to do here would not work. So the second concept we are going to look at is strings as primitives. Remember, we have primitive data types, right? And then strings are treated as primitive data types. Strings are considered as primitive. They are not objects. All right. So this means that while you can perform string operations on methods on strings, the string itself cannot be changed. We have seen string methods where you do string dot replace, string dot pad, string dot pad start, string dot substring, and stuff like that. We are not really modifying the original string there. No, but the methods are returning a new string for us. The original string was not modified. You need to understand this. All right. Whenever you're doing any of this stuff, they are not modifying the original string. They're only returning a new string that was created by the JavaScript interpreter. So look at it. When you say let name equal to Alice, and you now say name dot uppercase, it doesn't mean that this name here, okay, let's go to code and let me show you. I say let first name equal to Alice. All right. If I do this and I will now say f name dot uppercase. All right. What you'll be expecting is that you'll be expecting that this first name variable would be all uppercase. No, it doesn't work that way. If I still run this code now, we are still going to print the original string, which is Alice. But the thing is that this method here, it returns a string. It doesn't modify the original string. What it will do, it will return a new string. So I can now say let new name. I can say let new name equal to f name. Okay. If I do this and I'm going to print the two of them, you can now see that a new string was created and it was returned with this to uppercase. The original string is the fn, right? The first one. Why the new one is the second one. So if I run this now, all right, the original name still stays the same, but this uppercase method created a new string. It didn't modify the original one. It created a new one, and that is what was returned here. And that's what we are storing here. Remember, functions can return values, and this uppercase is actually returning the new string that it created. Behind the scene, it's going to create a new string that will all be uppercase, and it will return it. That means the original string was still the way it wasn't modified. So strings are immutable. So whenever you're using all these methods, understand that they are not they are not changing the strings. They are not really not modifying the string. They are creating new strings and they are returning the new string they created. Okay, so that is what we are saying here. Okay, this will return the uppercase of that version, but it doesn't modify the original variable, the original string. Okay, the next one, let us take a look at string methods and their effect, just like what we have already seen. String methods like concat, slice, substring, replace, they do not modify the original string. They don't. They are not modifying the original string. The original string will still be whatever it was. All right. Instead, they return a new string with the applied modification, just like we have seen in the to uppercase method. It didn't modify the original string. Rather, it returned a new string that has that modification applied. Okay. So let us see something here. We are saying let string equal to hello, and we are now saying string dot replace. Okay. We are now saying replace this replace E with A. All right. So this is going to return hello because the E was replaced with A. And if you print the original string, it is still hello, but the new string is hello, just like what you have just seen with the two uppercase. So whenever you're working with string methods, understand this effect. Pay close attention to these things, okay? This could be causes of errors. It could be, and most of the times, these errors are something that will be hard for you to figure out because they are logical errors. So you have to really pay close attention. That is why we are taking time to teach you this. Strings are immutable. Strings are immutable, okay? Even numbers too are also immutable. Primitive type, they are immutable, all right? New string or new number will be created when you're actually working with them like this, okay? So understand that. Now, let us also, the next concept we will take a look at is memory consideration. So the thing is this, because strings are immutable, each time you modify a string, such as concatenating strings or using string methods, a new string is created in memory. So you have to be careful. If you keep immutating a particular string, you're creating new strings everywhere in the memory. And your memory is not supposed to be taken up by your program. All right. When we start talking about performance, we're going to take a look at it. When your program should be using less memory, and this is what differentiates you from other people. This is what makes you a professional. When you write programs that do not take too much memory, all right? So you're writing a very good program. Now, if you understand string immutability, you'll be writing better program because you know that when you're doing concatenation or using string methods, you are creating new string in memory. So you have to use it with caution, okay? So this can be inefficient if done repeatedly in tight loops. So imagine when you're repeating concatenation everywhere, or maybe in a loop, 1,000 loops, you're doing concatenation. It could freeze your application because it could take a lot of memory. All right. So be very, very careful when you're working with string, especially when you're concatenating or when you're working with string methods, because they are creating new string in memory. And the more they are creating new string in memory, the more they are taking up your memory space. So if your application is taking too much memory space, it's a problem. Okay. So you should be writing code that are very efficient. Now, for example, when you're building a string by concatenating it with the concatenation operator in a loop, it can be costly in terms of memory and performance because a new string is created each time. So be careful when you're working with string and you're doing this concatenation, especially in a loop. Okay, so now better practice is use array.join or template literals when building string dynamically. Whenever you're building a large number of strings dynamically, use array.join method, although we haven't talked about arrays, all right, but use array.join method or use template literals when building string dynamically, as they are more efficient for repeated string operations. So when you have repeated strings operations, understand that whenever you're repeating string concatenation, it is taking up memory because for every iteration, for every concatenation, it is creating a new string in memory. You might not notice that. And that is why we are teaching you this. So whenever you're doing concatenation, all right, you are creating new string and it can take a whole lot of your memory. All right. So best practice is use array.join or use template literals when you're doing string concatenation. In short, basically from now on, whenever you're doing string concatenation, use template literals. You have been told here that they are more efficient. All right. What we mean by efficient, we mean that when you say that you're writing an efficient program, it means that your program will run faster and you're not taking too much of memory. So let us see this bad practice. Imagine that we are running this loop 1,000 times, and for each time we are doing concatenation here. For every iteration of this loop, we are creating a new string. Remember, what we are doing here is that we are creating a new string. That is what we are doing here. Understand that the original string is not being modified. A new string is being created. And what you're doing here is that you're going to create 1,000 string in this small program, which is very, very inefficient. It's a very bad practice. So basically, when you want to do string concatenation, use array.join or template literals. Make it as a habit, okay? A better way is this. You create an array, all right? Then you create an array, then you will now push, and now I don't know how to explain this thing to you because we haven't done array yet, but just understand this. First of all, you create an array. Instead of doing string concatenation, you create an array. Then for every iteration, you're pushing the string into the array. And at the end of the whole thing, you cannot do result.join. Don't worry, when we start talking about array, we are going to mention this join method and you're going to see how it works. So this is a better way of concatenating string. All right, this is a better way of concatenating strings, okay? So this will efficiently join the array into a single string. So instead of you doing concatenation using the concatenation operator, the plus operator, all right, it's better you use array.join this way, or you use string literal, the template literal, okay? Immutability and performance. JavaScript engines, they optimize string immutability for performance. All right. JavaScript engines optimize string immutability for performance, especially when operations involve concatenation, slicing, or other string manipulation. So by default, JavaScript is also actually helping us to optimize our program. JavaScript engines optimize string immutability for better performance. All right. So basically, when you're doing string concatenation or slicing or other string manipulation using other string methods, JavaScript is trying to optimize your code. Now, the engine may use techniques like interning, storing unique string values to avoid storing the same string multiple times in memory. Now, let me give a light explanation about what we mean by interning. Now, the thing is this. Okay, let's go to code and let me show you. Let's say we have this. We have let f name equal to John, all right, and let second name equal to John again, all right. So what JavaScript engine is going to do is this. JavaScript engine would create this string, this John string. It will create it in memory. That's normal thing, the normal thing you know. It will create it in memory and then assign it to this first name. Then when you now do again, S name equal to the same John, JavaScript engine is going to create something like we call string pools. It will create a pool of string where all the strings that you have in your program, they are all stored in that pool. So JavaScript will have a place in memory where it is storing all the strings that you're creating. Then if you want to create a new string, it will first of all go to that memory space where it has been creating all those strings and check if that string already exists. If the string already exists, it will not create a new one. It will take the old one and assign to this one you're doing here. So basically, when we have something like this, let's say middle name, and since middle name might be different, okay, all right, something like this. Normally, all right, you would think that I have told you already that for every string you create, JavaScript is creating that string in memory. So basically, we are expecting to have 3 strings in memory, right? John, and Doe. But that's not how it works. The first time, okay, maybe I should just bring this guy here to explain better. The first time, JavaScript will create this string John and have it in its string pool. The second time, it will say, okay, it will create Doe. First of all, it will check, before it will even create this John, it will check if this John already exists in memory. If it doesn't exist, it will create a new one. Then Doe, it will check again, does Doe exist in the string pool? If no, it will create Doe. Then the third line, John, it will check, do I have John in memory? Yes, I have John in memory. So there will be no need creating the new John. I will just make a reference, pass the reference to this S name because there will be no need. So this is a way that JavaScript use to minimize. Do you understand? This is how it's used to improve performance. This is how it increases performance. This thing I just explained to you now is what we call interning. It stores unique string values. So it's because it stores unique string value, it would only store this John once. It will only store one of it, because even if you now have another John everywhere, it would only create one John string in memory. And then any variable who is trying to reference that, it would map it to that one. So it would only create one string, one unique string in memory. You cannot have two Johns in the same memory, no. So this is how JavaScript actually JavaScript actually optimize string immutability. So this is a concept called interning. All right, storing unique string values to avoid storing the same string multiple times in memory. Just like we have created John. Why would you store another John in memory since you already have it in memory? So by that way, JavaScript is actually optimizing string immutability. I hope you understand it. But if you don't understand it, please click on the chat icon there and chat, raise the topic in the group if you don't understand, so that we can actually maybe have a live a better a live class for it and explain better. Okay, so now what are the examples of string immutability? Let's take a look at concatenation. This is the one we already know. Concatenation creates a new string. So whenever you're doing string concatenation, whenever you already know what is string concatenation, so I'm not going to go over to that example. You already know what string concatenation is. When you're using the plus operator to add to string, that is string concatenation. I believe you already know that. So that's what we are doing here. We have this variable greeting and it's storing the hello, all right, string. So we are now concatenating it with a space word. A new string will be created, and that new string that will be created will not be hello world, and it will not be reassigned to the greeting variable. So whenever you now call this greeting, it will not be hello world. It doesn't mean that this greeting didn't change. The string is that it contained changed. All right, the value that it contained changed. All right, it created a new string and then reassigned it to the greeting variable. That's how it works. Okay. Another thing is string reversal. Now, since strings are immutable, you cannot reverse a string directly. All right, you cannot reverse a string directly. You will need to convert it to an array first before you now do the before you can now reverse it. So you cannot reverse string because strings are immutable. Now look at this code. We want to reverse. All right, we want to reverse it. What can we do here? We cannot do string reversal right away, but here we were able to split it. We were able to use the split method. Remember that the split method, we split the string based on the parameter the argument you provide here. So we are saying for everywhere that we have empty space, split it. So as we are splitting it, it's returning an array. Remember, we did this split method. So when you call the split method on a string, it will create an array. Then in that array is what we are now doing chain. We are not chaining the method here. This split will return an array, and then the reverse will reverse the array. Okay, let's go to code. Let me just show you. Although we haven't talked about arrays, but let's just try. Okay, I have let str, try to understand as much as you can. Okay, let str equals to JavaScript. All right, and I want to reverse it, but I cannot do it on the string instead because string is immutable. What I can do is this: I can create a new string. I can call it new string or reversed string, anyone. And I will now say str dot split. The split method, this split method will return an array. All right, but I'm splitting based on this empty space. This will return an array. Then on an array, I can now call the reverse method because arrays have reverse method. And as I'm calling the reverse method, I am not joining them back. I will join them back. All right, so that's what we have here. Although we haven't talked about array, but just try to grab it. All right, so I am joining them with empty string. So don't worry, we'll talk about arrays and we'll talk about all these methods, but understand we already have. I will now console.log. I'll console.log the new string. All right, so here the split method will return an array. That's what the split method does. It returns an array. And once it returns an array, that particular array is what we are now doing. This thing I'm doing here is called method chaining. I'm calling 3 methods at a time because this one is returning an array. So I'm not calling it on top of this reverse method on top of the array. And whatever we got, we are not joining again. So this is like doing 3 things on this on different lines. So, but if I run this code now, you can see we got it reversed. But we were only able to do it because we were able to, first of all, convert this string to array by splitting it. We now split it and then we reversed it. Then after reversing it, we now join them again. But don't worry, we'll get to understand arrays better in the next chapter, okay? So why string immutability? Why is JavaScript enforcing string immutability? There are a lot of reasons. All right. Why is this string immutability very, very important? All right. There are a lot of reasons. So let us take a look at them one by one. Security and predictability. Now, by not allowing changes to a string once it's created, JavaScript ensures that string values remain consistent throughout the program. Now, the thing is this, it is very, very easy for you to make mistake and start changing. You might have a string somewhere and you don't even know when you have changed it. And once you change it, it will affect your whole program. So to prevent that, that is why JavaScript made strings to be immutable. All right. So once you have created it, any modification you're making on it would only create a new string. So it will not affect the original value of the string. Okay. Now, this helps avoid bugs where one part of the code accidentally modifies a string that other parts of the code rely on. And once you modify it, it will no longer work the way it's expected. So it can create errors, it can create bugs. And these are bugs that will be very, very hard for you to figure out. So understand that string immutability exists in JavaScript and it is very, very important. All right. So optimization. Immutable objects are easy to optimize for JavaScript engines. Now, if strings were not immutable, it would be difficult for JavaScript to optimize the string. And optimization is what we really need in our program. Because most times, if you write programs that are not optimized, it might not be working well. It might be taking too much memory. It might be taking too long to run. But JavaScript engines optimize immutable objects. That is why it is very, very good for optimization. So it's a plus, security and optimization. So when strings are immutable, the engine can apply optimizations like caching, interning. We have seen what we mean by interning and memory management techniques to make string operations more efficient. All right. So it is okay. It is very, very good for strings to be immutable because, first of all, security reasons, so that other code in your program will not go and change the values that you have, and you might not know where the problem is coming from. And secondly, optimization is very, very important. Okay. So for functional programming style, JavaScript immutability of strings aligns with functional programming principles, where data is not modified directly, but instead returned as a new value. Now, it is not good to be modifying data directly. Instead, when you modify, you return a new data so that the original data will be secured. Do you understand? So that is why string immutability is very good. Now, this approach makes programs easier to reason about and it avoids side effects. Side effects in your program is not good. So it's better that whenever you want to modify any object or a string, whatever you're modifying is returning a new data, a new string or a new object, not modifying the original data. Okay. So in summary, strings in JavaScript are immutable. Their values cannot be changed after creation. I hope this it has sunk in. All right. String methods that modify a string always return a new string, leaving the original string unchanged. So even in as much as you think that the methods that we have been using on string, they don't change it. They don't change the original string. And you can try it out yourself. All right. Keep the original one and modify it and see. Try it yourself and you're going to see. All right. String immutability leads to more predictable behavior and allows optimization by JavaScript engines. So it encourages functional programming practices where operations on data do not change the original data, but instead produce new values. And if you need to modify a string frequently, such as in a loop, it's best to use arrays or buffers, especially for large-scale manipulations. So whenever you want to modify string frequently, such as in a loop, always remember to use arrays or buffers. We haven't talked about buffers, all right, but in the next chapter, we'll be talking about arrays, okay? So that is it. Thank you very much. And make sure you do your assignment. Don't use ChatGPT to do your assignment. Make sure you write your text. And if you get confused, just hit the chat button by the right corner of this page, the bottom right corner of this page, and chat us up on the group, chat us up, let us ask your question, raise the topic, any topic you want us to treat. Maybe any of these classes you've been taking, you do not understand. Raise the topic, and once you raise the topic, we are going to treat it as well. We are going to do it in a live class and we can explain more, all right? Thank you very much, and I'll see you guys in the next session.